Hi guys, welcome to People Doing Stuff. This is episode 2 of Learning Electronics with Arduino. Today we're going to make our first circuit. In order to make our first circuit, you will need the following items. An Arduino Uno. You can get these on a bajillion sites. I bought mine on Taobao. Taobao seems to be the cheapest. But the boards might look slightly different because they're made by different manufacturers because this is an open source project. So don't fret if it's a little different. It will still have all the same inputs and outputs, just maybe in slightly different positions. So we'll need that. We will need a basic multimeter. Nothing special, just a cheap multimeter will do. I would just make sure it's digital and make sure it's fused. I left mine on. Don't leave yours on. It's a good thing it auto shuts off. My last one didn't. My battery would be dead. You're going to need your leads. If you're going to make your own jumper cables, you're going to need some wire strippers. Doesn't really matter what style you use. 22 gauge is best for breadboards. You will need a USB cable to plug the Arduino into your computer. You can also get wire strippers like this. I love having these just in my pocket. I've got probably 100 of them. You just kind of clamp the wire down with your hand and just pull it off. What else will we need today? You'll need a breadboard. Just a basic breadboard will do. Nothing special. Don't spend a lot of money on it. You'll need some jumper wires, 3 of them to be specific, but don't worry too much about them. You can just make them with 22 gauge wire or some old wire laying around the house. It just has to be small enough gauge or small enough diameter in order to fit in the little holes on your breadboard. Nice and easy. If you want to run your Arduino without the USB cable, you'll also need a 9-volt battery adapter, just like that there, with a little barrel plug that can plug into your Arduino to power it. And of course, if you're going to use this, you're going to need a 9-volt battery. The last 2 things we're going to need today for this project, oh no, it's just a cheap LED. And a 330 ohm resistor. So let's get started. So for starters, let's take a look at this breadboard here. Now on the breadboard, most of them will have an alphabet of rows at the top, alphabet of rows at the bottom, just telling you which row is A, which row is B, etc. You'll usually have a red line for positive and a blue or green or black line for negative here. Okay? And most of them will have this split down the middle. So here are a couple things that we need to know about breadboards. When you look at the breadboard, the positive line goes all the way across, which means every little one of these squares going across is connected. This negative line going across, they're also all connected. Same on this side. The negatives all the way across are all connected, and the positives all the way across are connected. However, these middle rows do not work the same. These middle rows work this direction. Row 1 is all connected. Row 2 is all connected. Row 3 is all connected, and so on and so forth. So if I were to put something here, 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 and here in row 1, they would all be connected. they would not be connected to this side's row 1. These are separate. They do not go all the way across, as you can see by the gap here. How these basic breadboards work is literally you just take the wire or the LED or whatever it is and they plug in. It's that simple. No soldering or anything required. Just plug it in to wherever you need to plug it in. Very, very simple. So this is a basic jumper cable. You can make these. Just take a piece of wire, strip the ends. 22 gauge works really well, or you can buy a set of jumper cables to go with your breadboard. Another thing we need to look at are these little tiny things. This is a resistor. Now resistors have all these little colorful bands on them. I don't think you can see them in this video very well, but just know that there's a bunch of colorful rings on here. Those colorful rings will tell you the resistance of that current resistor. Each color has a numerical value, and there's some really interesting sites, which I'll show you here in a minute, that will actually show you how to figure out what the rating is of the resistor that you have. Now this one here is a 330 ohm resistor, which we're going to use for our project today. The other thing we're going to need today is just a very basic LED. This is just like the super cheapo LED. And you'll notice that on LEDs that there is a long wire and a short wire. The long wire is your anode. The short wire is your cathode. So the anode being positive and the cathode being negative. Now, let's say somebody come along and they already use this LED and they cut it flat. If you look really closely at the LED, you'll notice that the plastic edge on that one side is shaved off to show you where negative is. Now our first circuit today is going to be very, very basic. We're just going to use the Arduino to turn on and off an LED using software. So before we program the Arduino, we're going to go ahead and set up our circuit here on the breadboard. So one thing we know we'll need is we're going to need a positive lead to go to the Arduino. We're also going to need a negative lead to go to the Arduino. Okay, so I just put those in the first row of positive, negative down here. Next, we're going to take the resistor. Doesn't matter which row you choose. And we're going to go ahead and use the resistor to come from positive into the circuit. So there we go. Resistor's installed. Now keep in mind the resistor doesn't have a positive and negative. It doesn't matter which way you face it. Now we're going to go ahead and plug our LED in. Remembering that the anode, the long side, is positive and the cathode, the short side, is negative. We're going to make sure that the long side goes with the resistor. And as long as I put it in this row here, then it's going to be connected to this resistor. But if I were to put it here, one over, now it's connected to nothing. It has no connection at all. So you do want to make sure that it's in the right one. And now we need to complete the circuit. So in order to complete the circuit, we need to take the negative side, the cathode. We need to plug it into that same row. And we need to take this side and plug it into the negative. Now we have a positive and negative to go into the Arduino. Now a multimeter is a great tool to have for your projects, especially when your projects get more complicated. This is just a cheap Chinese multimeter. These are called leads. You have a negative lead and a positive lead. The positive lead always either goes in this one on the outside or this one on the outside. Your negative lead is always going to go in COM in the center. Now, when we use the right side, it's using milliamps, and when we use the left side over here, we're using amps. So this side is fused. This is the side we're going to use for pretty much all of our projects using an Arduino. Now, we're not going to go through the entire use of a multimeter today. We're just going to start with the basics to check for continuity. In order to do that, we're going to use this setting right here. Just turn it on, and you should get a beep if you have a continuous circuit. So let's check. Yep, works great. The resistor to the LED. Yeah, we have a circuit there. So we know power is going there. If we run negative line to, yeah, we have connection there. So basically we have a circuit. Power's going through, that's what we're checking. From there, let's take a look at the Arduino. Usually on the side of your Arduino, you're going to have some listings. This is just showing you the number of each pin, so we know what pin to control, and it's showing you where the ground is. Okay? So we can use this ground by just plugging the power in, by plugging the ground line in. And then we can just pick a pin. So let's say we're going to do pin 10. Okay? The last step is to power the Arduino and run the program. Really simple. Plug it into your laptop. And it plugs into the Arduino. Let's go ahead and open up our Arduino IDE. Just going to drag this a little bigger. Make it easier to see. So, first thing we want to do is we're going to go to examples. Under examples, we're just going to click this one, Basics, and then we're going to go to Blink. Now, Blink is a simple program for controlling an LED. All it does is turn the LED on and turn the LED off. Let's go ahead and select it. Now that we have it open, let's go ahead and save it. We'll save it as Blink LED1. As you can see here at the top, you have a /*. This tells it to comment out the following information, which means it won't read this or use it for any code. And another asterisk and / down here, which ends the comment. Okay, this is for when you want to write paragraphs of comments into some code to tell somebody something or teach somebody something about the code. So this is telling us here what this code is used for. Turns an LED on for 1 second, turns it off for 1 second repeatedly. Very simple. If we scroll down, you'll also notice //. Now these // tell the software that you're also making a single line comment, and that comment ends the moment you hit enter. So right now this software is set up to use the built-in LED. The built-in LED, if you remember from episode 1, is actually pin 13. So if I were to erase this and just put a 13 here, it would do the exact same thing, because that's pin 13. Now on our Arduino project, we chose pin 10. So let's go ahead and change that to pin 10. So it's saying pin mode 10, and the mode is output. So it's telling the pin mode for pin 10 is use it as an output, which is what we're doing. We're going to send a on and off signal out of the Arduino. Now if you were taking information in from, let's say, a sensor that senses whether the light's on or off, then you would want to put input right here. Anyways, for this demo, pin mode 10 output. And that's all we need to change for our setup. Down here for the loop, you'll see that it says digital write. Digital write means it's telling it to write the code, or it's telling it to do something specific. So here it's telling us to turn the LED on. And how it's doing that is we're saying LED built in set to high, which means high voltage, as you can see right here. And the delay is 1,000 milliseconds, or 1 second. Down here you see the digital write LED built in low, which means low voltage or no voltage. Now we're going to leave those the same, but again, we're not using the built-in LED. We're using
pin 10. We're telling it to turn the voltage to high for pin 10, and then we're telling it to delay 1000 milliseconds before turning the voltage to low, and then delaying for 1000 milliseconds before turning the voltage to high, before delaying to 1000 milliseconds, on and on and on and on. And that's the basic code we're going to use today to run our first circuit. So once we're done with this, you'll notice we have a lot of different buttons here at the top. First, let's go ahead and save our project. Cool. And this one here is to verify. What I mean by verify is check the code and make sure there's no errors. So if we run verify, it's compiling the sketch. The sketch is what you call the code for an Arduino that you've wrote for a specific project. It's called sketch. Once it's compiled the sketch, it's going to check the sketch, make sure it's good, it's done, and it looks like there's no errors. If your Arduino is plugged in, you can go ahead and click upload. Serial port not selected. I selected you before. Let's try again. Port. COM5. Let's try again. It's uploading to the Arduino. Done uploading.
So, if everything is plugged in correctly, you've got your USB plugged into your computer, you've uploaded our simple Blink program that's been modified for pin 10, you've plugged your positive wire into pin 10 and your negative wire into the ground, you've got your ground going into the negative side and your positive going into the positive side, you've got your resistor connected from positive to the same row as the positive of the LED, and you've got your negative of the LED connected to your negative jumper back into the negative line. You should have a complete circuit. And as you can see, the LED is blinking on and off every second. So now we are controlling the LED with the Arduino. Congratulations on making your first program. Now, if your computer is still open, you can easily hop in, and let's say we change it to 10,000 milliseconds or 10 seconds. You'll notice that the LED is now staying on for 10 seconds. And if you wait just a little bit longer, you'll notice it's going to turn off for an additional 10 seconds. And so now you could play around with this, modify it how you want. I highly suggest trying to run maybe multiple LEDs and maybe even copying some of the program and increasing the length of the loop and doing different variables for how long the LED stays on. For instance, you could look up SOS and you could build an SOS LED based on the different timings for different messages. So, thank you for watching episode 2 of People Doing Stuff. I hope you've learned something about the Arduino today, and tune in next time for episode 3.